Slope deflection. Don't we all just love slope deflection? Welcome back everybody on my channel. Today I got something special for you. I've got slope deflection problem, structure analysis, all the engineering students out there. This is what you need to know, alright? Slope deflection. And with me I got a simple problem here, and I just thought it wise we'll go through it together. Alright. So the first thing you need to know when you're given a slope deflection problem, you obviously have the formula right here, right? This is the moment. This is the moment you have to find. Moment of near far equals to 2EI over L. 2 slope of the near plus slope of the far minus 3 psi plus FEM near far. Alright. So let's get into it. Here's the problem, everybody. I've got a beam right there. The distance in between is given as shown right there. And so let's get it cracking. So the first thing you need to know, or the first thing you actually need to do in slope deflection problems, the first thing you need to do is determine the fixed end moments. And you should be able to get a list of all the fixed end moments, and you can just pull this off right from Google, or you know, at the back of your book. You have this information at the back of your book. So, and here are all the formulas of all the fixed end moments, just depending on what type of beam you're given. And let's just go ahead and do this. So I do have my fixed end moment, and this is how we're going to start this problem. Fixed end moment of AB, right? AB right there is equal to, so what I do, I come back to my sheet here, and then so from A to B, I do know that I have two loads right there. So I come back to my sheet here and I look for a similar type of load structure, and I find out if only this thing can zoom in right here. Let's see, zoom in, come on, there you go. So right there, you see the 2P, the two loads right there? So the formula, the fixed end moment in that case is gonna be, come on, focus right there, focus. There we go. So you can see fixed end moment AB is 2PL over 9. So come back right here, and now this is gonna indicate a negative. Why? Because of my sign convention, and in this case I'm gonna have my sign convention be like this, like that, and that's gonna be positive. So because of this, this is gonna end up being a negative, and like we said, it's gonna be negative 2PL over 9. Now when you sort this out, this is gonna be minus 2 times P is given by 3. All right, that's our load, times the length. The length is going to be 3. All right, my bad. The length is going to be 3 plus 3. Okay, this is point A and that's point B. So 3 plus 3, that's going to be 6 over 9. All right. Actually, sorry, my bad. The distance is from A to B is actually going to be 9. Right? I'm so sorry, I forgot about this. So it's going to be 3 plus another 3. Making it a 9. All right, so these will cancel, and then we just end up having negative 6. All right, so this is my fixed end moment AB. Okay, I do the same for fixed end moment of BA, and this time it's going to be the same, but it's going to be a positive. All right, again, according to our sign convention, it's just going to turn out to be a positive. So it's going to be 2PL over 9. Okay, and this is going to turn out to be positive 6. There we go. All right, next I'm going to find my fixed end moment of BC. All right, so come back to my beam right here, and BC, from B to C, I just have a beam and I have one load right there. So I'll come back to my sheet right here, and I look for a similar type of structure, and I find out that it's here, right here. Right here, you just have one load, put it in the middle. Okay, so that means my fixed end moment BC is going to be PL over 8. All right, All right, so come back here. Now, again, always going to be a negative. Why? Due to the sign convention. So I'm going to have minus PL over 8, okay? So minus P, remember, that's our load right here, and it's going to be a 4. So come back down here, 4 times distance. What's my distance? My distance is going to be from B to C, so that's going to be 10 plus 10, that's a 20, all right? So it's going to be 20 over 8, all right? When you solve this, you end up getting a negative 10, all right? And all these are just keep feet, okay? Always remember to put your units. Don't forget your units, very important, okay? Keep feet. All right, so next I have to come back here and get the fixed end moment of, again, CB. Always go to the front and come back again. So this is now going to be the same, but only positive, all right? So I'm going to have, my P is going to end up being 4. Distance is 20 over 8. That's going to make it positive 10. Keep feet, okay? So here I have it. I've calculated all my fixed end moments, all right? I have AB, and I have BA, then I have BC, then I have CB, all right? All right, so let's proceed. What's the next thing we have to do? The next thing you got to do, everybody, listen. Very simple. The next thing you got to do is find the moment itself, okay? And as the formula says up here, so the first thing we just did is just determine this fixed end moment. So right now, because the ultimate goal is for us to calculate the moment, all right? Just for example, the moment of AB. So it's just going to be 2EI, and all these are fixed. They're constants which are provided. And all we got to sort out right now is this term in, parentheses right here, right? All right, so let's go ahead. I'll just flip this over. All right, so the next thing I'm going to do is start off by saying, this camera is not going to focus so well here. All right, there we go. I apologize for all this. So next I'm going to say moment AB equals to 2EI over L. And then I have this term in parentheses plus theta B minus 3 psi plus FEAB. Obviously we have this. We've calculated for that already, okay? So here I go. So my moment AB is going to be equal to 2EI over L. Now what's my L? My LAB. Okay, come back here. LAB is going to be 9, alright? So come down here, that's my distance, okay? So now, when it comes to this term in the middle right here, this theta, that symbolizes your slope, right? And then so this is going to be slope at A, slope at B, okay? Now, according to our diagram right here, according to a beam, when you have a beam being fixed at a certain point, that means there's no slope over there, okay? So that means my slope at A is going to be 0, and my slope at B is B, since it's not fixed, that means we do have a slope there, all right? And then obviously, since C is also fixed, that means we don't have a slope right there, okay? So whenever you have a fixed beam at a certain point, that means we don't have any slope at that point, all right? All right, so that means this term is going to go to 0, and then now what psi means, and I forgot to talk about it right here, and let me just take a moment to explain what this means. So psi is equal to sediment over the length. Now this is only applicable when you have a sediment in the problem, and according to our problem we don't have any sediment, so this is ultimately going to turn into a 0, okay? So I come back here, so that means also this term is going to go into a 0, so I have this being 0 and a 0, so I just end up having a theta B, all right, plus my fixed end moment AB. And when I come back here, my fixed end moment AB, I found it to be minus 6. So I come here and I say minus 6. All right. So that's my moment AB. Again, I do the same for my moment BA. It's going to be 2EI over same distance because AB is the same as BA, all right? And now, this time, what do I input in the middle here? I'm just gonna, it's the same formula, only that I start off with B, all right? So it's gonna be 2 theta B plus theta A minus 3 psi, okay? Plus FEM BA, all right? So do we have any slope at B? Yes, we do. So that means this term does not go to 0. But do we have any slope at A? No. So that means this term goes to 0, all right? And obviously we don't have any settlement in the problem, so that goes to 0. So what do we end up having? We end up having a moment AB equals to 2EI over 9. And then we just end up having 2 theta B. What is my fixed end moment BA? Come back here. Fixed end moment BA, we found it to be positive 6, all right? So I'm just gonna plug it right here, plus 6. So here we go, everybody, okay? So right now, I'm in good shape, really. I'm confident. I got everything I need. I've got the two moments, AB and moment BA. And then what's left is just to calculate the moments BC and CB, okay? Again, the same procedure. Don't panic, okay? This is just easy stuff. Just gotta follow the process, all right? So, next I'm gonna find moment BC. Again, the same formula, okay? EI over L. Now, we'll come back to the diagram here. Now we're dealing with BC. And what's my distance? I got a distance of 20, if you can see it right here. All right, so come back down here, and my length is going to be 20. All right, so, excuse me. So I'm going to end up having 2. So where do I start? I start off at B, so theta B plus theta C minus 3 psi plus F. This is my fixed end moment, BC, all right? Now, ask yourself here, do we have any slope at B, at point B? Yes, we do have a slope. So that means this is a certain number. It's not 0. Do we have any slope at C? Now, as you remember before, as I told you, at all the fixed points, that means we don't have any slope. And at C here, as you can see, this point is fixed. That means the slope is 0. Likewise for point A, all right? So that means this goes down to a 0. And then we still don't have any settlement to the problem, so that means this goes to a 0. So my moment BC is going to end up having, so I can just say by 2, 1, by 2. So EI over 10, this is 2 theta B. Now what is my fixed end moment BC? Come back here, this is it, and it's a negative 10, all right? Make sure you take care of those signs. Make sure if it's a negative, you indicate it as a negative. If you put it positive, you're going to end up getting something totally different. All right? So this is it. So that's my fixed end moment, BC. Again, go back. Now look for CB. Again, same process again. All right? Over 20 because it's the same distance. And now, since I'm starting at C, it's going to start off by having theta C plus theta B minus 3 psi plus fixed end moment of CB. All right? All right. Do we have any slope at point C? No, 0. Do we have any slope at B? Yes. So that term remains. And no settlement, 0. So what does this end up having? This ends up being EI over 10, just theta B, all right? So, and then what is my fixed end moment CB? Come back here. It's 10, all right? Fixed end moment CB equals to 10. So plug it in there, plus a 10. Boom, you're done. Simple. Simple as taking a smoothie. All right, everybody. So, what do I have? I do have. So let me just recap here, just real fast, okay? So the first thing I did is calculated all the fixed end moments. Why? Because in my equation, I'm required to know what the fixed end moment is, all right? So I calculated all the fixed end moments, and then I went ahead and calculated all my moments, okay? I got my moment AB, as you can see right there. I got my moment BA, all right? Then I got my moment BC, all right? The camera, excuse my camera, everybody, it's just not focusing here. Then I went ahead and got my moment CB, all right? Can you see it over there? Perfect. All right, so the next thing I'm gonna do here is, and this is the turning point, okay? This is gonna be the turning point. So, you're gonna form an equation here, okay? And say MBA plus MBC, okay, equals to 0. And this is very important. This equation is a turning point, okay? So what does this mean? It means that, all I'm saying is that the moment of B, the moment from B to A plus the moment of B to C must be equal to 0. That's what I'm trying to say here. And this is true, okay? So what do I gotta do here? So I have everything. I calculated all these moments. I do have the moment BA and I do have the moment BC. All I gotta do is just come back to my equation here of moments and just, you know, just plug and chug, basically. So BA, let's find it. So I'm gonna have 2EI over 9 times 2 theta B plus 6. Okay, I just wrote it down here. That is my moment BA plus, okay, plus moment BC. Come back here and locate BC. This is my BC right here, okay? So that's gonna be EI over 10, 2 theta B minus a 10. All this must be equal to 0, all right? All right, cool, there we go. So basically what is left is just basic algebra right here, okay? And let me just go ahead and multiply here. So 2, that's going to be 4 EI theta B over 9 plus the 6 plus, okay, that's that. So this ends up being 2 EI theta B over 10 minus a 10 equals to 0. So when you manipulate all this, you must end up having EI theta B being equal to 6.027, okay? And you want to leave it in this form because this is going to be very simple when it comes to plugging it back into the equation for you to obtain the moments themselves, okay? Because, so what's going to happen next is that I got this value here, okay? And the next thing I'm going to do is just come back to every individual moment that I got and just plug it in here for me to be able to get the moments as a number, okay? And that's what we're going to do right now. All right, so we're going to start with moment AB. My moment AB, I got it as 2EI theta B over 9 minus 6. That was my moment AB, okay? And you notice that this EI theta B is same here, EI theta B, okay? So that means instead of EI theta B, I'm gonna plug in 6.207, and that's what I'm gonna do right here. So moment AB equals, and I'm apologize if I'm going too fast. I mean, you can always fast forward this if it is clear to you, and this is just basic algebra right now, okay? So I'm gonna have 2 times 6.207 over 9 minus 6, and this, my people, ends up being negative 4.621 feet. All right, so this is my moment AB, okay? Flip the page Next, let me try to get moment BA. Moment BA, all right? That's gonna be equal to 4, as you can see, 4 EI theta B over 9 plus 6, okay? And remember, we got EI theta B as 6.207. So, and this value is the same here, EI theta B. So I just plug that in place of this. So I'm gonna end up having BA equals to 4 times 6.207 divided by 9 plus 6, all right? And this ends up being 8.759 feet, all right? This is my moment BA, everybody. All right, next, calculate moment BC. All right, moment BC, come back up here. What did we find it? Okay, there we go. So moment BC is EI over 10, 2 theta B. Okay, we have a 2 theta B minus a 10. So come back down here. Just plug it in. Instead of EI theta B, I have 6.207 over 10 minus 10. And this ends up being -8, sorry. Whoop. I'm losing my touch here. 59 feet. All right, that's it. That's my moment BC. And then finally, this is the moment where we've all been waiting for, CB, which is gonna be my last moment. CB, everybody, is equal to EI theta B over 10 plus 10, all right? So come back down here. So EI theta B, that's equal to 6.207 over 10 plus 10. And this ends up being 10.621 feet. And there you go. There you have it, everybody. So let me just quickly go through the main steps that I did to complete this problem, okay? Like I said, this is a very simple problem, okay? Slope deflection. So there you have your beam, all right? Now the first thing you need to do is make sure you calculate all the fixed end moments, okay? And the fixed end moments, we get them from this sheet provided either at the back of your book, or you can just Google it and print it out, okay? You have all the fixed end moments here. And you get all the fixed moments just according to the structure. If you have a fixed end beam here and it has 2 loads, you go to the sheet and look for the same structure, and then it will have its own type of equation, and you know, you just plug it in there. So that was the first thing. I calculated all my fixed end moments. Then after doing that, I then proceeded into calculating all my moments, okay? Now, in my moments equation, I do have my fixed end moments equation attached in there too. And I have that middle equation right here. And then through that, I mentioned that you're going to have your slopes in there. And then slope at A, we do know that since it's a fixed end, and slope B, since it's also a fixed end, we do know that the slopes right there are equal to 0. However, the slope at B is going to be a certain number, which we don't know, and which that's what we're finding, okay? So after calculating all my after calculating all my moments, I go ahead and just okay, here's a very important equation. Remember the equation I wrote, and I told you that that is gonna be your turning point. Here we go. This is a very important equation right here. The moment of BA plus the moment of BC must be equal to 0. This is your guiding equation, and this is what you should follow. So after that, just plug in there all the equations, you have them, and just make sure they're equal to 0. And then finally calculate all your moments. All right, And there you have it, everybody. If you have any more questions, feel free to comment and just shoot me an email, or if you're interested in more questions or any particular specific questions, just feel free to email me and I'll be more than happy to share with you all my solutions. All right. Otherwise, stay focused, stay blessed, and hey, keep the grind going. Never give up. Keep the grind going. All right, everybody, catch you in the next.